right, 8.2 is on angles and radian measures. There's two different ways to measure angles, and one is in degrees, that's what we're used to, and then there's also radians, which we're not as used to. All right, so an angle in standard position, the starting angle part, okay, so basically one of your sides is always going to be right here on the x-axis, going that direction. Very, very specifically, starts at 0, 0, and it goes to the right, okay? So it's basically the positive x-axis. And then if you draw any other line coming off of this, that's technically an angle, and it's in standard position. All right. So that's what I need you to know about that diagram. All right, other things you should know, this is 90 degrees, this is 180 degrees, this is 270 degrees, and if we went all the way around, we'd be going 360 degrees all the way around the circle. All right, so if they wanted you to draw an angle with a given measure in standard position, what you'd have to know, okay, you'd have to know that you always, your first line always goes this direction. Now again, if this is 90, this is 180, if this is 270, 240 must exist somewhere in between 180 and 270. And again, I don't need you to get a protractor out. I would just need you to know that the angle should go somewhere down here between 180 and 270. Now, of course, 240 is closer to 270 than it is closer to 180, so the angle would look something like that. All right, if I ask you to draw a 500-degree angle, what you need to know, so again, that's always how you draw your first side, okay? Well, again, 90, 180, 270, 360. Now, what's 360 plus 90? 450 would be here, so we'd be 50 degrees past 450, so we would be like here-ish. Okay, and again, I don't need it to be exact, I just need you to understand where it would end up. Now, what I need you to know about a negative angle, instead of going counterclockwise, which is how we're always going to run these, so again, these are going to go counterclockwise. Counterclockwise, so again, we went 90, 180, 270, 360, 450 to 500. Negative just means we're going to go the other direction. So instead of going 50, we're going to go 50 this way. So again, the angle would look something like that. Okay, so again, notice my angle and that angle looks pretty much the same. They drew like a little red thing right there. It shows you that it's 60 degrees past 180. All right, and here they drew like a little red squiggly. That shows you that you went all the way around once. Okay, so again, if we went around once, that'd be 360 degrees. So then we'd have to go another 140 degrees to get our angle. And again, notice their angle and my angle look pretty much the same. I mean, I'm pretty good at guessing where 500 degrees is without a protractor. And then notice their 50-degree angle and my 50-degree angle. It looks pretty much the same. Okay, and again, all it means is that you're going to go clockwise instead of going counterclockwise. Cool. So let me put this in a different color. So again, your first side is always going to be right here every single time. So again, if you understand that this is 90, and again, I don't need you to pull out a protractor. All I need you to realize is that 65 is a little bit closer to 90 than it is to 0. Okay, so again, this distance would be 25 degrees, this distance would be 65 degrees. Again, it's just an estimation. I don't need you to pull out a protractor for this. I don't honestly care all that much. All right, so again, you start here. We always go counterclockwise unless, of course, the angle is negative. So if I'm going 300, well, this would be 90 degrees, this would be 180 degrees, this would be 270 degrees, which means 300 degrees is 30 degrees past 270. So right there is where I'd end that angle. All right, this is our start. That's 120. Just kidding, that's 0. It's negative, so we're going to go clockwise. So this is negative 90. This is negative 180. Well, 120 is 30 degrees past 90. So again, it would be closer to this than it would be to this one. And if I needed to go negative 450, well, again, my first angle always goes off to this side. Okay, well, this is negative 90, negative 180, negative 270, negative 360, 360 plus 90, negative 450 would be straight down. Okay, so again, standard position, you should always have an angle pointing over here. and then figure out where it would go from there. And again, I don't need you to pull out a protractor. I just need you to be able to estimate about where that would go. Now again, if we wanted to draw the little squigglies, I would technically only draw it on this one, because this is the only one where we went all the way around 1. So we went all the way around, and then we went an additional 90 degrees. This one, again, we just went 120 degrees this way. This one we went 300 degrees this way. This one we went 65 degrees this way. So again, there's little arrows for you in case you like the little arrows. All right. So that's angles, standard position. Next page. There it goes. Finding a coterminal angle. So you might realize that when we went around that thing all the way around, okay, so if we started here, well, if we went around 360 degrees, we'd get right back to where we started. Another 360 degrees would get me right back to where we started. Well, we could also go clockwise, which means we're going negative 360 degrees. So every time we go around 360 degrees, it ends up right back to where we started. That's basically what a coterminal angle is. So finding one positive angle and one negative angle that's coterminal with negative 45. To do that, all you have to do is add and subtract 360. And 395, well, here you might just want to subtract 360 twice, because again, if you need one negative angle, if you add 360 and subtract 360, you're going to get two positive angles. All right, so there you go. I'll show you they added 360, they got 315. 315 degrees is the same exact line as negative 45 is. Okay, negative 45 is again the same thing that negative 45 would equal. Because again, if we were to draw it, again, same line. They're the same exact angle every single time. So there's actually an infinite amount. You could keep adding 360. You could keep subtracting 360 to find as many coterminal angles, but we're only looking for one positive and one negative. Now, notice how I said on this one that we should probably just subtract 360 twice. Okay. So again, you could add 360. You would get another coterminal angle. And again, there's no real wrong, well, there's wrong answers, obviously. But again, if you took 395 and you added 360 and you told me that one coterminal angle was 755, what? 755. I do not know why this is not writing the way that I want it to. I would count that. But if I ask you for one positive and one negative, if you told me 755 and 35, then I'd mark that wrong because they're not one positive and one negative. So again, this is also coterminal. We could find an infinite amount if we just keep hitting plus 360 or minus 360. All right, coterminal angles, again, if it's between 0 and 360, all you have to do is add and subtract 360. So we're going to do positive and negative 360. Okay, so we're going to do 80, we're going to subtract 360, we're going to get negative 280. Negative 280. And we're going to add 360. 80 plus 360 would give me 440. Okay, so one positive and one negative. 230, again, that's between 0 and 360. So again, I'm just going to add and subtract 360 from 230. That's a 6. All right, 230 minus 360 gives me negative 130. That's one of our answers. And again, these are in degrees. I don't mark off if you don't use the degree symbol. I'm not that picky about weird things. All right, if I take 230 and I add 360, if I hit the right buttons, I get 590. And again, there's actually an infinite amount of these. If you wanted to find the next one and not use 130, if you wanted to do extra work and you wanted to subtract 360 twice, that would also give you another negative angle. If you wanted to add 360 twice, that would give you another positive angle. All right, 740 is bigger than 360. So instead of adding and subtracting 360, I'm going to subtract 360 twice. Okay? So again, 740, if I subtract 360, I would get 380. I'm going to have to subtract 360 3 times because 380 degrees is coterminal with 740. So again, keeping on with my pattern, if I subtract 360 again, I get 20. So those are both coterminal, but it doesn't satisfy the question, which is asking you find one positive and one negative. Well, these are both positive. So we're going to hit that again, minus 360. That's going to get me down to negative 340 right there. So if I needed one positive and one negative, pick one of these, or pick, I don't care which one. Again, but you pick also this one. One, doesn't matter. And again, if you really wanted to go above and beyond and be weird, you could just subtract 360 again, but I don't recommend it. All right, negative 135 is between negative 360 and positive 360, so again, we're going to do the same thing. We're going to add and subtract 360. So the only time you have to do it more than once is if it's bigger than 360 or smaller than negative 360. So negative 135, we're going to add 360. So one of my angles that's coterminal is 225. And negative 135 minusing 360 gives me negative 495. So again, if we were to draw these angles, all of these angles would be the same exact measurement. Right there. All right. So again, one positive, one negative, one positive, one negative, one positive, pick one, and then pick the negative one positive, one negative. All right. The last part of today is converting into radians. Okay, where radians come from, I don't truly know. I've never been that interested in figuring it out. But going all the way around the circle is considered 2 pi radians. This is pi radians. This is pi over 2 because it's half of the pi, which is weird because you think of the pi as the whole circle. This is 3 pi over 2 because if this is 1, which is weird because it's half of the circle, it's half of a pi to me, but half of the circle is considered pi, all the way around the circle is considered 2 pi, so again, this would be half of the pi, 1.5 would give you here, 2 all the way around. All right, cool. So here we go. If we're going to convert 4 degrees into radians, you're going to put 180 degrees on the bottom, and you're going to put pi on the top. And I write pi radians. I don't write radians because I'm lazy. All right, 180 degrees, pi on the bottom, that is to convert radians to degrees. So again, I don't write radians because I do find that very, very strange. All right, so again, all you're going to do, if you're converting from degrees, you need the degrees to be on the bottom because then the degrees are going to cancel each other out. And if we have 120 over 180, again, some of you are still not reducing your fractions. You do need to reduce your fractions. 120 over 80, those are both divisible by 10. 12 over 18 is both divisible by 6, so we're going to make that 2/3 pi. And again, the pi is going to be in the numerator. Right there. We're converting from radians, and we know it's in radians because it doesn't have the degree symbol. That's how you're going to know if it's in radians or degrees. If it has a degree symbol, it's in degrees. If it doesn't have the degree symbol, it's in radians. Well, radians means you put the pi on the bottom, you put the 180 on the top. We're going to do some cancellations and some reducing. So cancel the pi's. Pi's goes away. 180 is divisible by 12. I don't happen to know what it is off the top of my head, so I'm going to put it in the calculator. Okay, 15. So again, keep the negative sign that's out in the front. Negative 15, and this is in degrees, so we're going to put the degree symbol just so you guys know that's in degrees right there. Whoop. So radians, degrees. So this radian is the same as this degree. This degree is the same as this radian. All right, cool. And hey, look, I got the same answer that the book got. Awesome. So that tells you I kind of know what I'm doing. I don't know. All right, cool. So here we go. We're going to convert the degree measures to radians or the radian measures to degrees. So again, these are in radians, and we know that because there's no degree symbol. These are in degrees, and we know that because there is a degree symbol. So when you have degrees, that tells me that the 180 goes on the bottom because then the degrees cancel each other out. And that tells me that pi goes in the top. So again, what I'm talking about, that little dot right there actually gets to cancel with this little dot right here, which is how we get out of having degrees. I'm going to reduce, so again, I'm just going to put it in the calculator, 135. I'm going to hit the B/C button, 180, and again, that's how I use my calculator to reduce my fractions for me. All right, that's 3/4, and again, the pi goes in the numerator. Now we'll talk about what this means in terms of on a circle later on in this chapter. again, the same thing. If this is in degrees, that means our degrees have to go on the bottom because, again, if we put 180 and we actually use the degree symbol, which, again, I don't care if you use it, right there, this little circle, boop, can cancel with that little circle, boop, and we're going to reduce. So, again, 40 over 180 is going to reduce into 2 over 9. And a couple things that we need. One, we need to keep that negative. So if it's negative, it stays negative, and we need to put the pi in the numerator. Right there, we've converted into radians. If it has the pi symbol, that's how I know it's in radians. The other way that it's in radians, this one's in radians. If it doesn't have the degree symbol, then I know it's in radians. So again, in radians, go on the bottom, because again, that pi is going to cancel with this pi, slash, slash. We're going to have 5 times 180. And then we're going to divide that by 4. So 5 pi over 4 is the equivalent of 225 degrees. This next one we're probably going to have to round, because in degrees we don't use fractions, we use numbers. So again, because we're converting from radians, and again we know it's in radians because it doesn't have the degree symbol, we're going to put the pi on the bottom. We're going to plug this into the calculator. Negative 6.28 times 180 divided by pi equals negative 359.817. I don't know what they want you to round to. Let's round to 2 decimal places like money. So the 7 tells me to round that 1 up to a 2. And this is in degrees. We'll put the little degree symbol there. That way we remember, hey, we just converted that into degrees. So again, your radians usually have the pi in it. This is an example where it didn't, but usually radians have pi inside of it.